This is the second section of the algorithms chapter on flowcharts. Now, what is a flowchart? A flowchart is just a way of listing a set of instructions or a process using sort of different boxes. Okay, so we'll just write that down. So a flowchart is a way of listing instructions or a process. Now, there are strict rules about flowcharts, and you'll see flowcharts will have different types shaped boxes in them, and depending on the shape of the box, it will tell us exactly what we need to do. And it's important that we know what the different shapes tell us. Okay, so these are the different shapes we need to recognize in a flowchart. So the first one here will occur at the start or the finish of a flowchart. Okay, so you'll see this shape at the start or the end of a flowchart. The second type of shape we get, this rectangle, it will be an instruction. So if you see a rectangular box, inside the rectangular box will be an instruction. It will be a process, something that you need to do, a step that you need to follow. Then the last shape is like this diamond shape, and this one is what we call a decision. And with this decision, normally what you get is there'll be some sort of question in here which you might answer yes or no to, and depending on your answer yes or no will decide which way you go. So it might be, if the answer to your question is no, you follow the route of the flowchart this way, and if the answer is yes, it might go this way. Now, it may not be yes or no this way round, or on these sides, they may be on this side, for example, but it's always some sort of decision. And once you answered the question, then that will decide which way you follow. And all of these different types of things will be joined by a line. So for example, you might have a flowchart that starts like this. It has maybe a couple of instructions like this. Then there might be some sort of decision we need to make. So for example, have you got to 0? Is one number greater than another? Something like that. And then it may be that once we've answered that question, this might be yes, going this way, and then no may take us to the end of the flowchart. Okay, so here's an example of what a flowchart may look like. Okay, so here we have a flowchart with an algorithm, so you can see the start and stop boxes. You can see the boxes that contain instructions, and here we've got a decision box, and depending on whether the answer is yes or no, we'll go straight to the end, or we'll go back to box 3. So let's implement this algorithm using a trace table. Now, a trace table is basically a table that just records our list of instructions. So we'll just write that down. A trace table, it's just to keep us organized, is a table that records our actions, what we're going to be taking, and results. So the headings of this trace table are going to be any variables that we have, so any letters that take a value that could be changed. So n is 1, see n there, and e is another. And then I also need to record the results of any decisions that I make. And so this column here is just going to have yes or no's in it, depending on the decision we make when we get to box 6. Okay, right, so let's go through this. So it starts by saying let n equal 0. So that's box number 2. And we move to box number 3, let n equal n plus 1. So that's got to go in the next row. Let e equal 2 times n. So that will be 2 times 1. So that's 2, not e. Then print e. So actually when we print something, it's basically like writing down what the results are. So we can write down print, or we can write down output. What's the output? So the first output is going to be the number 2, and then it says, is n greater than or equal to 10? So the answer's no. So then if the answer's no, that means we go back to here, increase n by 1, double n to get e, print e. Is n greater than or equal to 10? No. So we go back, increase n by 1, double 1 to get e, print e. Is n greater than or equal to 10? No. Add 1 to n, double n to get e, print e. Is n greater than or equal to 10? No. Increase n by 1, double n to get e, print e. Is n greater than or equal to 10? No. Increase n by 1, double n to get e, print e. Is n greater than or equal to 10? No. Increase n by 1, double n to get e, print e. N is still not greater than or equal to 10, so we add 1 again. We double it to get e, we print e. N is still not greater than or equal to 10, so we increase it by 1 again. We double it to get e, we print e. N is still not greater than or equal to 10. We increase n by 1, we still double it, and we print it before we get to the decision. So we still print a 20, and then it says, is n greater than or equal to 10? Well, it is equal to 10, so the answer is yes. So then we go to box 7, and we stop the process, the algorithm, the program is over. Okay, so that was our output for part A. Now part B says, alter box 4 to read let n e equal 3n. Okay, so let's change that to n to 3n and see what happens. So we're still going to have the same headings, n, e, box 6, like this. So n still starts off with 0, we still increase it by 1, we double it to get e, we print e, so we're still going to have an output. So we basically need to list the output, I think, before we can decide what the how the algorithm changes. So oh no, it's not double e, is it? It's 3n this time, so that should be 3. So the first output is 3. N is not greater than or equal to 10. Right, so increase it by 1, times it by 3. Okay, we can almost do this automatically now. So 6, 9. So it's a 3 times table this time, isn't it? 12, 15, 18, 21. So let's do a few more rows. 24, 27, 30. Okay, so it's going to be 18, 21, 24, 27, 30. So we still print 30 before we say n is greater than or equal to 10. So then we get to box 7 and we stop. So how's it changed? Well, it alters the algorithm. We now get multiples of 3 instead of multiples of 2. Okay, so the output is the first 10 multiples of 3, not 2 as it was previously. Okay, so we've got this flowchart here. So if I was doing this, I've got my sort of trace tables ready, is go through and see what the headings need to be. So I can see I've got A, B and C and D. as my variable, so just highlight those A, B, C and D. So let's put those in as headings. A, B, C, D, A, B, C, D, A, B, C, D. I suppose it would help if I got my alphabet the right way around. What else do we have? We've got two decisions here, so we need to put some decision headings in. Now here, the decisions aren't labelled as like box 4, box 5. So we just put down the question that's in there. So D less than 0, D equal to 0, D less than 0, D equals 0, D less than 0, D equal to 0. Now there's going to be some outputs where we've got this, where it says print. Now the output could be X, or the output could be X1 and X2. So for the moment, I'm going to leave these boxes blank because I don't know whether it's just going to be X or X1 and X2. I'll find that as I go through the question. Right, let's start with the first quadratic then. So input A, B and C. So that's going to be 6, -5 and -11. Okay, second instruction box here, let D equal B squared minus 4AC. So that's going to be -5 squared. It's basically the discriminant. -5 squared minus 4 times 6 times -11 without my calculator, and I get 289. Right, so I've done that. Is D less than 0? Okay, it's not. So the answer to that is no. Is D equal to 0? So again, the answer to that is no. So I've followed the no route. No down there, no down there. So I'm now going to have two routes, x1 and x2. So now I can put the headings in, x1, x2. And the way that I find x1 and x2 is by doing this calculation here. Okay, so what we're going to get here is 11 over 6. It's just a quadratic equation because we've already worked out b squared minus 4ac, and that just goes there. And for x2, I just replace the plus before the square root with negative, and I will get -1. Okay, so that's the first one done. So we now move on to the second quadratic here. Input A, B and C, so that's 1, -6 and 9. D is going to be B squared minus 4AC, so that's going to be -6 squared, which is 36, minus 4 times A times C, which is also 36, so we end up with 0. This thing here, is B less than 0? No. Is D equal to 0? This time the answer is yes. Since it's equal to 0, we do this calculation, so there's only one output, x. And I suppose we should write down all our results here. So for A, it's x1 equals 11 over 6, x2 equals -1. Then for B, we do this calculation, so x is -b over 2a. So that's minus -6 over 2 times 1, 2. So -6 divided by 2, or 6 divided by 2 is going to be 3. So for B, the output is just 3. C, input A, B and C again. So 4, 3 and 8. Work out B squared minus 4AC. That gives us -119. Get to this box here, is B less than 0? The answer to this one is yes. So then we print no real roots. No real roots. So we'll just put down here no real roots as the output. Okay, I've got another algorithm here. So I can see that I've got set of values that I'm going to start with. All these are going to perform part of the algorithm. My variables, well, n gets increased by 1. So n is a variable. We'll put that in our table. First column, we want to keep a note of which box we're in. So we'll just put box here. We can put the box number. What other variables do we have? Well, A is going to be set to something, and A changes as well. So I'll put A. Then we also have T is equal to something. That's going to change because we've got this sub n, and that's going to, as n changes, that's going to change. There's no other variables, but we have got two decisions. Is T less than A? And the other one, n less than 5. So we'll just be writing yes or no. Right, so let's start with box 1. Let n equal 1 and A equal to U1, so it's going to be 10. Box number 2. Increase n by 1. Okay. Box number 3. Let T equal Un. So T is going to equal U, n is 2, U2, so it's going to be 15. Box 4. Is T less than A? Is T less than A? The answer to that is no. So we don't go to 5, jump to box 6. Box 6. Is n less than 5? Is n less than 5? The answer to that is yes. So now we move back to box 2. Box 2, increase n by 1. Let T, so this is box 3, let T equal Un, so it's U3, so it's now going to equal 9. Next one, box 4, is T less than A? Well, the answer to that is yes, it is now less than A. So we now go down here, let A equal T. So this is box 5. So let A equal what T is, so A is now 9. So we move on to box 6. Is n less than 5? And the answer to that is yes, because it's only 3 at the moment. So we've done that, we go back and now increase, in box 2, increase n by 1, so it's now 4. Let T, box 3, equal Un, so it's going to be U4, so it's 7. Now box number 4, decision to be made. Is T less than A? And the answer to that is yes. So if the answer is yes, we can go straight down to box 5. Box 5, let A equal to T, so A now is going to be 7. Okay, now box number 6, another decision to be made. Is n less than 5? The answer to that is yes, it's still less than 5, it's 4 at the moment. So since the answer is yes, we go back, increase n by 1, so box number 2, n is now 5, so we might be coming to the end. And so yeah, it's box number 5, box 2, box 3, let T equal Un. So T is going to equal U5, so that's 11. Notice that each box, each instruction just has its own row. Don't try and squash it all onto one row. Right, box number 4. Is T less than A? Is T less than A? The answer to that is no. Alright, since the answer is no, we go around this way, and we went that way right at the very start. And then it's is n less than 5, so this is box number 6. Is n less than 5? The answer to that is no. So now we go down to box 7, and it says print output is A. So output is, and it's whatever A is, and A is 7. So I could even put on the table here, output is 7. You should now be able to do exercise 1B on pages 9 and 10. So I'll just do a quick recap. So I think we'll probably just talk about trace table. So with a trace table, this is what we're going to do to record our results. Now in the headings of this table, what we want, if it's a flowchart with box numbers, or maybe just put box here, we'll have a couple of columns, 2 or 3 columns with our variables. So there are things maybe like n and whatever variables that we have. And then we're going to have columns where the headings are the decisions that we need to make. So they're basically going to be the questions that are in the boxes. And then in these columns we will write things like yes, no, for example. They will go in those columns. Remember, we just want 1 row per instruction. Don't try and squash them all onto 1 row. So 1 row per instruction or box. And with our flowcharts, just remember these symbols here. You might be asked what these mean. So start or end for that rounded box, for a rectangle here, that's an instruction, and the diamond here is going to be a decision box. And when you have the word print in as an instruction, that's basically your output. That's basically what you're going to write down. And it's normally some sort of list of numbers or letters, something like that.